Hello everyone, welcome to this video. In today's video, we'll be looking at the decorator design pattern. So what really is the decorator design pattern? The decorator design pattern is just a structural design pattern that allows you to be able to add behavior to an existing object. It's actually a structural under design patterns. It's under the structural design patterns. So let's say, for example, we have uh, three shapes and we have two colors, so yellow color and a green color, and I wanted to have uh, shapes with this particular color. So if I was to do this, I will have a square with that is yellow, a circle that is yellow, a rectangle that is yellow, a triangle that is yellow, a rectangle that is green, a circle that is green, and a triangle that is green. That will be the situation. So I will need to create 6 classes only because I'm trying to be specific for these scenarios. So imagine tomorrow we needed to add another color. So let's say the orange color. It means that for each of them, we still need to go and create the respective. So for example, we'll have an orange square, an orange circle, and an orange triangle. Now, imagine if we have a shape, a new shape, we wanted to, let's say the star shape. So it means we need to also go ahead and create classes. Just because we wanted to add one shape, we need to add a new class for yellow star, green star, and an orange star. Now that looks okay. Okay, that looks fine. That looks like okay, it's manageable. But this scales up exponentially. So for example, imagine you have 20 shapes and 3 colors. That would be about 60 permutations. So you need to create 60 classes. That is kind of burdensome and it's not efficient because it means if I make a change, it means I need to go to all of them and make the changes. So let me even try to push this a little bit forward. So let's say we have 4 shapes as we've said, and we have 3 colors, just as we've said. Now, if we could combine colors such that we can have a greenish yellow, so it's possible to have a square that is green, yeah, greenish yellow, something like that, for example. So we'll be coming up with almost 28 permutations just because we want it, just for 4 shapes and 3 colors. So you see, we have a yellow square, we have a circular blue, we have a triangular green, we have a circle that is greenish yellow, we have that bluish green, and we have different colors. And that will be, imagine just for because we wanted to have 4 shapes and 3 colors, we need 28 classes. So the developer, as a developer, you have to go and build up these 28 classes. That is not efficient, and that is not, it doesn't look nice to do. So how do we solve this? We can use the decorator pattern. With the decorator pattern, you can have just these shapes. For example, you can just have uh the square shape, the circular shape, the triangular shape, and your star shape. Fine. And then you can have some like an addition. So we can call them additions just for explanation's sake. All the yellow, the green, and the blue. And so we just mix these permutations within them. Because at the end of the day, it is the combination of these 4 shapes and 3 colors that form all these 28 items we have here. So let's look at how it looks like in the code. So here, this is a console application, and it's based off of .NET 7, but it's a console application, just a simple console application, and it's for like a house renting system. So imagine we have a a a situation where we advertise houses. So we could have a bungalow, we could have duplexes. So let's say, for example, we have a bungalow that is having a car park. Another bungalow could just have a swimming pool. A bungalow could have a lawn. Another bungalow could have both a lawn and a swimming pool. And we want all of this to be able to put all of this together. Decorator pattern shines it. So we'll look at it without the decorator pattern. We'll look at it with the decorator pattern and see why it's something we must have in our toolkit. So if we go into the option without the decorator pattern, we see that we have just a bungalow. So it's possible to just have a bungalow without car park, without a lawn, and without a swimming pool, for example. So if you look at this, for example, this is just a bungalow with it's just a bungalow, and so it will just say tell us the bungalow has so room. So if uh if we look at this, we have for the car, we have the combination with the car. So you see, for example, this when we are building this house, we see that this bungalow has 0 rooms with bathrooms with the particular number of bathrooms or toilets, and then we add that it has a car park in the advertisement. So for example, let's say we have a one that has the three combined. So we have to come here and put this bungalow has this number of rooms, this number of bathrooms or toilets. It's located in this place. It has a car and has a swimming pool. And when we have the combination of the three, that will be this. So you see here we have it's going to show that it has a car park, a lawn, and a swimming pool. That's how it looks there. And this looks kind of tiring. So imagine tomorrow we needed to add a new uh type of house. So instead of just a bungalow and duplex, we have a story building, for example, maybe 3-story building, 4-story building. So imagine for a 3-story building, for example, it means I will need to go and create a class for 3-story building, for a 3-story building with a car park, with a lawn, with a swimming pool alone, then with the different permutations and combinations there. That could be so tiring. Imagine if we also wanted to add something like another addendum, let's say veranda, that will if this house has a veranda. The permutation just exponentially keeps growing and growing, and that would have been what we would do if we wanted to use without the decorator pattern. This is so for just 2 houses and for 3 addendums, that is the car park, the lawn, and the swimming pool. I needed to create 18 different classes. That is tiring. Now, but with decorator pattern, we find what we have at the end of the day will be something a little bit simpler. So in the decorator pattern, there must be a base that is like an interface or an abstract class that everything comes from out from. So let's say, for example, so we see here that this interface just shows that it's to build a house. The only method it implements is the build house method. So basically a house has to be built. The house has to be built. So for example, here we have just a duplex and a bungalow. So if you look at it, the bungalow, just like the previous one, it has the number of rooms, locations, number of bathrooms, and all of that. And that's just basically what it says. So this just tells us this is a bungalow and has so rooms. And for duplex, it says this duplex has so number of rooms, and that's fine. Now, where we have our decorators is now here, and with that, you need a base implementation for your decorator. So, for example, we have our base house decorator, which we also inherit from the same interface. For example, the iHouse interface that we have here. And you see, it passes in what it will also pass in as a parameter in the constructor. It has to be what that base interface is, which is the iHouse, for example, here. And then we have a protected read only just here to get it. So now when we go to the 3 decorators we have here will be the car park, the lawn, and the swimming pool. Those are the 3 attachments we have. So we want the core at the core of it is that we want a bungalow or a duplex. Now, but with these things, we want an attachment of either a car park, a lawn, or a swimming pool, or any combination of it, depending on how it comes. So when we look at the car park, you see it will just inherit our abstract class, which is the base house decorator. If I go back to the base house decorator, the base house decorator is inheriting from the I house. And so when you look at the car park decorator, you see that basically we're just passing in a house, a high house interface, and whatever implements that. And then what we are doing here is when it's a car park decorator, we are adding the fact that it has a car park. If it is a lawn decorator. We are calling whatever implementation of the house built house we have in the implementation. For example, in our bungalow, we're calling that base implementation there, the implementation in that I house, and then we are adding the fact that it has a lawn, and the same thing, it has a swimming pool, basically. And when we want to make use of it, so if I go back to the program.cs, permit me, I will comment out what we have in this place. So if, let me just, for the node decorator, I will just go down. If I show us what we have here and I just run it before we see it, we see clearly that um, for example, here we have the bungalow in England, and basically I just need to create a bungalow, and I passed in the rooms, the bungalow bathrooms, and the location, for example, which is England here, for example. So if I also have another one, I could. So now, if I now want a bungalow with a car park, all I need to do is to have my decorator and I pass in the bungalow. So based off of this now, a bungalow with a car park. So if I should comment out all of these and just leave out, so that we just, for clarity's sake, I'll comment out all of this and I was to run this. So let me run this now. So this is a bungalow with a car park, and I'm trying to build that house. Now put in mind that it was all I just needed to do was to create a bungalow, and to the decorator for a car park, I passed in my bungalow. So if we run this, let's see what we have. We see that what we have here will just be, this bungalow has 3 rooms and 2 bathroom toilets, and it's located and then it has a car park. So just by doing this, I didn't need to come here and create plenty different implementations. All I needed to do here was just to create my houses, the core implementations, which is the duplex and the bungalow. The core structure there is the duplex and the bungalow, and then the addendums, the additions, the decorators. We have our car park, the lawn, and the swimming pool, and that's all I needed to do. So it is now left for the user to, okay, I want a bungalow that has a car park with a lawn. So a car park with a lawn, it means that we have something like, when we want a car park with a lawn, so that would be this. So you see, we are passing in a bungalow with a car park into this lawn decorator. So if I was to come here, let me just copy this, just a minute, copy this, and I should run this. Let's see what we have here. So we see that what we have here is that this is telling us that it's a bungalow with 3 rooms and 2 bedrooms. It has a car and it has a lawn. So I didn't need to create specifics, like for example, without decorator, where for this I needed to have created a bungalow with a car park and lawn class. Just with creating a bungalow and a duplex, and then I created the decorators, which are the car park, the lawn, and our swimming pool. I was able to come up with this. So I just needed basically 5 classes to construct, and I can construct any of those 18 permutations that I had without the decorator. So for example, let's say tomorrow we needed to add a new building structure, let's say the 3-story building. All I just need to do is, here I just have another class here, which will be a maybe 3-story building that we take from iHouse, and I will have its own build house implementation there. And then that's all I need to do. And when a user who needs a 3-bedroom flat with a swimming pool, all he needs to do is create the swimming pool, create create the 3-bedroom flat, and pass it into the constructor of the swimming pool, and then boom, we have it as we want it. So it reduces the hassle of having to create multiple classes. So this is very, very useful when you have a lot of permutations or possibilities of how things can go. When the possibility keeps expanding exponentially, it's always best to go with the decorator pattern. I hope with this video we are able to learn 1 or 2 things And thank you, and see you in the next video.